welcome on board. This is Design D engineering process, and this marks our first content for this channel. On this channel, we will be given a walkthrough on process engineering operations and design. Please make sure to subscribe, like, and click on the notification icon, as this will help us to grow as a channel and motivate us to bring more insights on engineering processes to you. Let's dive in. So for this content, we will be using an application called Aspen HYSYS. Aspen HYSYS is a powerful process simulation software used in chemical, oil and gas, and energy industries. It enables engineers to design, optimize, and analyze process plants by simulating behavior of fluids and gases within their systems. So, for you to create a new modeling and simulating environment, you click on case. That's like the new environment stuff. It brings you down here. This is how the whole home environment looks for a new case. On the left hand side, you can see that we have about 6 categories, 6 items for the simulation. Before you engage in any simulation, there are a couple of things you need to carry out. So we have about 6 here, but for the beginner's journey, we will only be sticking to about 2 of them: the component lists and fluid packages. So the component list. The component list is a collection of chemical components that will be used in the simulation. For every simulation, every process, you do need products, and component list and fluid package are basically like the parts where you select the products for the process, the whole simulation stuff. Over here, we have properties and simulation. This is where the whole simulation takes place. But before you do carry out the simulation, you have to select the properties, the whole properties. The component list, we'll start with the component list. Down here, we have the add button and the import. The import is only when you do have the component list installed on your computer. You can import it inside the Aspen HYSYS. But for me, I love sticking to the pre-installed component list inside the Aspen HYSYS software. When you click on this down arrow, you see that we do have 2 categories, the HYSYS and the Aspen properties. For the beginner's journey, let's stick to the HYSYS. When we move forward in the future, we get to talk about the Aspen properties. HYSYS. Over here, you have a list of different chemical compounds, properties. For this video, we'll be sticking with methane. Let's add ethane too. So methane and ethane. With that, we have successfully selected our component list, our products, and you can see down here that we do have a blue tick here signifying that yes, it has been successfully added, and the status can tell us that it's okay to go. It's green. Next on, we have the fluid packages. The fluid packages, just like the component lists, it does have about 3 categories under it. When you click the down arrow, the HYSYS, Aspen properties, thermal. You still get to stick with the HYSYS for the beginner's level. So we have a bunch of different fluid packages. What the fluid package basically is like it defines the thermodynamic methods and properties models that will be used to calculate physical properties like density, enthalpy, phase, equilibria of the components in the simulation. It's like the second stage of selecting your products for the simulation. You're adding the properties and the mathematical thermodynamical formulas that be used to convert those products for processes and simulations. Penn-Robinson. Mostly when dealing with hydrocarbons, we tend to stick with Penn-Robinson because it's very versatile and flexible in the whole thermodynamic property thing. So to keep things easy, we'll still stick with Penn-Robinson for this. And with that, we have successfully selected our fluid package. You can see the status down here, so it is okay, green, good to go. After doing these 2 things, you're good to go. So we click on the simulation to get down to the simulation environment. this is the simulation environment, and it's empty because we haven't added anything, we haven't started anything yet. And this is our model palette. The model palette is supposed to look like this, just on the left-hand side. But for me, I customized it to have more space on my modeling environment. So if you want to do that, you can just move around with it and add it down here. And click on this pin, and that's it. If you want it to pop up, you click on the model palette. So for us to start our simulation, we do need to create streams. What are streams? Streams are basically the product, the feedstock for the process. How do we create streams? We come up here. It's clearly labeled streams. We have two types of streams, material streams and energy streams. So since we are adding products, we are to use the material stream, the dark blue. We drag it down to our environment, and you can see that it's boldly labeled as 1 with a very beautiful sky blue color. What the sky blue color means is that basically the stream is empty. It has nothing attached to it. You double click on the stream, and above here you can see the stream name, which is very much customizable. Let's name ours methane. So after naming our stream methane, we should bear in mind that the stream name does not affect our modeling in any way apart from reference, meaning that it doesn't affect the value we would be having after the modeling and simulation. Whatever product we'd be having, it doesn't really affect it. We only do the naming of streams to actually reference, to trace, to know what stream carries what exactly and what are the properties inside the stream. I find that very convenient because it saves time and a lot of stress, thinking, finding, doing the trial and error to know what stream carries what exactly. And I would advise the beginners to actually stick with that. It makes things very easy and faster. So inside the material stream for methane, we do need to consider two things as beginners, majorly two things. Let's keep our head around them: the conditions and composition. Under our composition, you can find methane and ethane here. Remember that this methane and ethane are the two components that we selected from our component list. If we had selected like about 10 different components, we'd be having 10 different components down here. All the 10 components we selected, we'd be seeing them here. What Aspen HYSYS expects from us is that we assign values of compositions, how much of every single composition is present inside the stream. For every single composition that we're working with, how much of it is present there, so that it knows how it affects the whole simulation process to get our products. Bear in mind, before you start assigning values for your composition, bear in mind that the composition ranges between 0 and 1, in the sense that it doesn't go below 0. 0 is the minimum value for a composition, and 1 is the maximum value for a composition. What 0 signifies is that 0, if for example I have a 0 for methane, it signifies that the methane there is 0%. Look at it from a perspective of percentage. Methane is 0% for 0. And if I'm having a 0.5, it can actually occur in decimal. It doesn't really have to be whole numbers of 0 and 1. It can be in the state of decimal. Let's say, for example, I have a 0.5 methane. That means it's a 50% methane, if you look at it like that, because it has a range of 0 to 1, and 0.5 is the middle. It's the mid. So if we're looking at it at a perspective of percentage, 0.5 should be 50% methane. Remember, it doesn't go above 1 in the sense that 1 should be the maximum level. So if I'm having 1 as my value for methane, it means I'm having 100% methane. Going by the reference that we made for this stream, we named it methane. Logically speaking and thinking, this should be a stream carrying solely methane, 100% methane, which means that our value to be assigned for this stream would be 1. Now, look at this, the right-hand side, composition basis. It's expecting us to select the basis that we want to work with. We want to work on the mole fraction basis, mass fraction basis, liquid volume basis, whichever we wish. Let's work with the mole fractions. You can see it. We still have to select a value for ethane. That's what you think. That's what everyone thinks. But Aspen HYSYS is so smart that it knows there's a maximum value for everything. It's just like the total here. Remember that same ideology for the range between 0 and 1? It's still applicable to the total. The total doesn't go above 1 and doesn't go below 1. That's the whole composition total, telling us that we have the whole total for all the composition listed should amount to nothing more than 1 and nothing less than 0. So having 1 here and ethane being empty, automatically Aspen HYSYS knows that we are expecting our ethane to be 0%, and 100% methane, which is 1 here, the overall total, the maximum value. Let's say, for example, we try to override that rule of the maximum value of 1 and we assign another 1 here, making it 100% methane, 100% ethane. It's given us a total of 2, and we think that that's actually successfully added rather, as a composition. But when we come back here, we can actually see that it does an auto correction for it to actually make sense. 0.5 methane, 0.5 ethane, that's the best we can get if you actually want to stick with that maximum value that is naturally programmed on Aspen HYSYS. A total of 1, it doesn't go above 1. So we're having 0.5 methane, 0.5 ethane, meaning that we're having 50% methane, 50% ethane as our composition. But that's not what we're looking at. For a stream solely named methane, strictly named methane, you should solely have a value of 100% for methane. So that's 1, maximum value 1. And this should be raised. It's empty right now, but Aspen HYSYS knows that it's 0. So and this is it, the total is 1. So when we press OK, Aspen HYSYS does the needful for us, making it 0. Our total is 1, and we have successfully added the composition. So if this was like a stream of methane, ethane, we could select the composition of, maybe we would be wanting 70% methane, 30% ethane. If we wanted an equal amount of composition, we'd say it's a 0.5 methane, 0.5 ethane, meaning 50% methane, 50% ethane. But this is solely methane, a sole methane stream, so it's 100% methane. Now we are done with the composition, back to conditions. There's a whole lot of properties that we can see here, but we don't really need to freak out. We only consider 4 properties here as beginners, basically. And to keep things simple, we only consider 4 properties, out of which we are only to assign value to 3 of them. So what we have here, let's look at the first 6. Vapor fraction, temperature, pressure, molar flow, mass flow, ideal liquid flow. For this mass flow, molar flow, and steady ideal liquid flow, they are basically the same thing, talking about flow rate. So any one of them that we assign a value to would suffice as a flow rate. Let me show you what I mean. Remember that we are working with mole fraction basis. So to keep things simple and better, we would work with the molar flow, attaching a value of 1000 kilomole per hour. You can see the units here. This is the SI unit, and you could actually change it to whatever you wish. Gram mole per hour, million metric scoff per hour, million metric standard cubic feet per hour, million metric standard cubic feet per day. Whichever you wish. It doesn't really have to be anything specific. Whichever you find more convenient, you could use. But for me, I love sticking with the SI unit, so we would work with kilogram mole per hour. Click on that, and you can see that Aspen HYSYS beautifully, smartly gives us a conversion of what our flow rate at 1000 kilomole per hour would look like in a mass flow rate of kilogram per hour. That's 1.604 exponential 4. That's basically about 16,000. Yeah, 16,000 kilogram per hour. And in a steady liquid volume flow, cubic meter per hour, that's about 53.58. So with that, out of the 4 properties that we need to consider, the 4 properties that we need to consider, the flow rate, the pressure, temperature, and phase fraction, we have assigned 1 out of the 3 that we need to assign a value to. We have assigned flow rate. Up next, we have our pressure. The pressure it's self-explanatory. It's talking about the pressure at which the stream exists. So Let's say it exists at 20 bar, just like the flow rate, you could actually change the units. I love sticking with SI units, 20 bar. Temperature. So for the temperature, if you do not have, normally when you're working with a product, you normally have the temperature at which you're working with. So you can assign all those values, the temperature, the pressure, the flow rate, you do normally have them on ground. So you assign the values. Then another thing that you should take note of is that Aspen HYSYS, anything you see highlighted in black, it means that Aspen HYSYS automatically imputed that value for you. You do not manually impute it, and with that, you cannot manipulate that value. But for the ones highlighted in blue, you're free to manipulate them because you manually imputed them. So temperature. Let's say it exists in about a temperature of 100. Now, the reason why we are considering four properties is because we want to stick with these 4 properties because they are easy and self-explanatory. And when you are working on a process, an operation, you do normally have them on ground. That's the flow rates, pressure, temperature, and vapor fraction. But luckily enough, Aspen HYSYS does a very beautiful manipulation of finding the 4th one when we assign only 3 values. It doesn't allow us to assign 4 values because it causes a consistency error. It doesn't really allow us to impute 4. It's normally 3 values. The moment we impute the 3rd value, it automatically finds the value of the 4th one. It does something much more like an iteration. I don't know. It's programmed like that. So we're about to impute the 3rd value, which is the temperature. And this is the vapor fraction up here. And just watch what it beautifully does. That's it. We have our vapor fraction automatically given by Aspen HYSYS highlighted in black as 1. And this green background having OK here signifies that we have successfully created a stream. Please bear in mind that even though we do not manually impute this phase fraction value, vapor fraction value of 1, you can see it's highlighted on with a black color. It means Aspen HYSYS automatically gave us this value. Given that Aspen HYSYS automatically gave us this value, it doesn't really mean that we cannot give a value for the vapor fraction ourselves manually. Let's try that. We raise the temperature expecting Aspen HYSYS to give us the temperature automatically, and we impute the vapor fraction of 1. And we have our temperature. If you look at this, you can see we have a variation from the initial temperature we're having. The initial temperature was 100 degrees Celsius. Manually imputing our vapor fraction as 1, Aspen HYSYS gives us a negative 107.6 Celsius. That's a variation. And the reason for this variation is that Aspen HYSYS tries to mimic the real-life scenarios and applications for every single chemical compound we work with. It tries to give us how, as accurate as possible, it tries to give us the property and behaviors of each and every one of this chemical compound, how they behave, how they exist in real life for us. But at the same time, when Aspen HYSYS tries to do this, giving us the real life behaviors, it still leaves a room for flexibility. And this flexibility exists in ranges. Like, for example, earlier we're having 100. It means that even at a vapor fraction of 1, which is solely gas for this methane stream, a pressure of 20 bar and molar flow rate of 1000 kilogram per mole, Aspen HYSYS tells us that our stream can still exist at a temperature of 100 and at the same time a real life temperature, a real life scenario and behavior having a temperature of negative 107.6 Celsius. It's all about the ranges, so it doesn't really mean that we're having wrong values when we do things vice versa, having manually imputing our vapor fraction and having a different temperature, or manually imputing a different temperature and having a vapor fraction. The vapor fraction rarely changes because of the temperature, because of us manually imputing the same temperature rarely changes. Let's try that. Okay, so we're expecting Aspen HYSYS to give us an automatic value again for the vapor fraction, but this time around we're using negative 107.6 Celsius, like it automatically gave us earlier, and we still have the same vapor fraction. So Aspen HYSYS just tries to give us the most accurate value you can get for its real life behavior, but leaving a room for flexibility for us to impute our values that we want to work with for a process. Another thing you need to know before we move away is these two things I'm having here highlighted on yellow. The active button and the on hold button. They are basically nothing more than a pause and play button for simulation and modeling. The active is the play, the on hold is the pause. When you pause it while modeling and you make any change, let's say for example I change this to changing it to about 10 bar. Oh yeah, 10 bar. Aspen HYSYS cannot carry out the successfully create a stream for me because we're on hold. It cannot apply any change without me clicking on this active the play button. After doing that, successfully creates a stream for us again. This is it. So it's just basically pause and play, pause and play. And you will see the importance of this when we move forward on our next content. And I believe that should be all for stream creations. Or rather we could try something. We'll try something again. Let's create another stream. So Aspen HYSYS has this very convenient feature of, instead, if I want to create a clone for this methane stream, instead of manually adding every single data from the composition to the conditions, I could just define the stream, basically carrying the data of the stream I want to copy, methane stream that we created earlier. I carry the data, press OK, click in methane, click on OK, and it automatically brings the same data. You can see this is our stream 1, and this is our methane that we created earlier. And if you look at it, you would see that they do have the same properties, exactly the same properties, because we used the methane stream to define this new stream that we created. But nevertheless, I just wanted to be a little bit lazy. Let's name this stream half methane half ethane. So going by the name of the stream, we're expected to manipulate. The conditions should remain the same to keep things easy. From the conditions, the manipulation should take place in the conditions. And going by the name half methane, half ethane, a range of 0 to 1. Let's just leave it at 1. We're having 1 as our total for the composition. When we're talking about halving it, we divide it by 2, since we have 2 components here. Dividing by 2, that would be giving us a 0.5, 50% methane, 50% ethane, half. So we say 0.5 methane, and Aspen HYSYS will automatically give us a 0.5 for the ethane too. It should. What's going on? 0.5 methane. And normalize. We could just do this beautiful thing where Aspen HYSYS does a manual, the same automatic process thing of giving us the value of other components. Normalize. No, it doesn't work that way. 0.5 methane, 0.5 ethane. And with that, we have a total of 1, 50% methane, 50% ethane, mole fractions basis. Okay. And with that, we have half methane, half ethane stream, 50% methane, 50% ethane. And you can see something very, very nice here. Doing a comparison between the two streams we have, half methane, half ethane, and 100% methane, you could see that we're having the same molar flow rates, the same pressure, the same temperature, but our vapor fraction varies simply because we added ethane as a composition and the composition changed. So you can actually see how it affects the properties of every single stream. Adding a composition from the composition to the percentage of the composition, it just does a whole change to the stream. And if you check down here, even though we're going a little bit outside the beginner's circle, but if you check, you could see that the heat flow changes. It's a negative 2.3, and over here we're having a negative 1.925. So that's about it for creation of streams on Aspen HYSYS. Hope this video is very helpful to you, and please, if you haven't, do remember before you leave to drop a like, a comment if you found this video very helpful, and most importantly, click on that subscription button and notification so you can motivate us to create more content. Thank you very much.